All right, you guys, so number 40 is starting a quadratic regression, right? And so I'm going to kind of highlight this really quick. Okay, so it says to create the quadratic regression equation for the population of a colony around your coefficients of your function to the nearest hundredth. All right, so we want to make sure we're reading our directions and they're telling us how to round. Okay. So they're giving us a table of time in years of a colony of something. I don't really know. Oh, it says rabbits. Never mind if I read there. Right, so this is a rabbit colony. So this is going to be your X and this is going to be your Y. So at year 0, which is when they started, there were 700, because notice it says 100, 700 rabbits. After 1 year, there was 500 rabbits. 2 years, there was 100 rabbits. So they're declining. But then after 3 years, there's 200 rabbits. 4 years, 900. So they're growing. So they're declining and then growing. So we can kind of tell this is going to be a quadratic regression just by looking at the numbers. All right, so remember we are going to have to use Desmos for this. We're going to go put our table in, and then we're going to type our quadratic regression, which is y1 approximately ax sub 1 squared plus bx sub 1 plus c. So you have to type that in exactly like that into Desmos for it to run a quadratic regression for you. Okay, so here we go. I'm going to go to Desmos. All right, so you hit the little plus sign and hit add table, and then we need to enter that entire table in, right? So 0, 1, 2, 3, 4, 5. And then 7, 5, 1, 2, oops. We don't want to mess up our table. 9 and then 11. All right, and then you totally want to look at your screen here and you can kind of see a quadratic curve kind of happening. It's not a perfect curve because no data in the real world is going to be perfectly quadratic, right? Which is why we want that regression. So I'm going to go into my line 2 over here and I'm going to type in that big long quadratic regression equation, which is just your standard form, ax squared plus bx plus c, but you've got to put x sub 1s and y sub 1s because that's how our table is labeled. So here we go. So y1 is, approximately, and then we need a x sub 1 squared, you got to get all that in there, plus b x sub 1 plus c. There you go. And you want to double check, right, to make sure that the quadratic they're giving you looks reasonable, right, as far as following that curve. Okay, I'll lower that down. And what we're looking for here is right here, right? They're telling us the approximate A, B, and C values that would plug into this quadratic function, okay? So, and we're going to round to the nearest hundredth, remember. So A is going to be 1.14, B is negative 4.77, and C is 7.29 if we round to the nearest hundredths, okay? So I'm going to go back to my Notability, and I'm going to write all of that down, all right? I'm going to write them over here really quick. 1.14, the B value that they gave us was negative 4.77, and the C value was approximately 7.29. So I'm going to use that information from Desmos to come over here and write y equals 1.14 x squared, there's my A, minus 4.77 x, because that's my B, and then plus 7.29. All right, and then the secondary question, of course, the whole reason we do this is so we can make predictions, right, about what may happen in the future or in between these 0 to 5s. But it says, predict how many rabbits there will be in 8 years. Well, 8 years, that's time, right? So that's our X variable, right? Time in years. So they want us to plug in an 8 for the X's and see what we get out for the Y's. Now you can do this by hand if you want to, by taking your equation that we just found, and everywhere we see an X, we can plug an 8 in. Right? This is essentially what that's asking us to do. Right? What is the Y value when X is 8? Now, this is going to give us a little bit of rounding error if we do it this way because of the fact that we rounded everything to the hundredths place. So, which is totally fine. I'm I'm going to use Desmos though, right? Again, you can kind of, let me shrink this down. You can kind of follow your finger until you get to the 8, right? We talked about this in class, but you got to get it right on the 8. Oh, I went past it, right? It's so hard to get smack dab on there. Oh, I was there. Boop. There you go. Right, so about 42, right? Or remember we talked about how you could also type in x equals 8, and it'll put that line there for you so you can actually just tap the gray dot, because it'll make a gray dot at any intersection, and that way you don't have to do that with your finger. So you also can see you get that 42.257, so that's another option. But either way, you're going to get about 42. All right, so I'm just going to write about 42, and it's hundreds, so technically it's 4,200 rabbits, right? Because you need to pay attention to the table, right? The table doesn't just say that we're talking about rabbits in hundreds. Okay. All right. Next one. Timmy has to jump over a river for a movie stunt. Okay. Use the table below to answer the following questions. All right, so here's his data. So clearly he's going up and over, right? So we're definitely looking at a quadratic, right? I don't know what the quadratic is that matches this data, so Desmos to the rescue, right? I'm going to let it run all that for me. So I'm going to go back here, take all that away, go to my table. All right, this is a nice short table. So 1.5, 2, oh, I was trying to let it automatically fill in, but that is not what I want. So 1, 1.5, 3, and 4.5. There we go. 16, 21, 24, and 9. All right, notice that nice little parabolic curve that's happening with those 4 points. Okay, I'm going to run a regression. Here we go. Y1, approximately x sub 1 squared plus b x sub 1 plus c. There we go. And look at that beautiful curve, right? Do you notice how it's going perfectly through those points, which means his jump was perfectly parabolic, which makes sense. And so our numbers are going to be nice, pretty whole numbers, as you can see over there on the left, right? The A value is -4, the B is 20, and the C is 0. All right, so I'm going to go back over here. All right, I'm just going to write those numbers down really fast. So A was -4, B was 20, and C is 0. So that's going to allow me to write the quadratic equation, y equals -4x squared. That's my A value in the front. Plus 20x, that's my B value. And if you want to put the plus 0 on the end, you're more than welcome to, but I'm just going to leave that off. All right, then once we have this equation, we should be able to answer a whole slew of questions. And we also have it in Desmos, so we can just kind of use Desmos too. All right, so it says, what is Timmy's height at 2 seconds? All right, so seconds is time, which is the x. So I can literally just take my equation and plug a 2 in everywhere I see an x. And what is that going to give us? Let's see, -16 plus 40, so 24. And that would be 24 inches. Okay. I can also, of course, just go to Desmos. I can type in x equals 2 because that's what I know. And then I can just tap on that intersection point and it'll tell me that it's 24 inches for after 2 seconds of time. All right, what is Timmy's maximum height? All right, I'm going to go to Desmos for that, right? Because the maximum height is going to be the vertex of our parabola, right? Now, remember, I don't want you to give me the answer. I don't want you to write the vertex as the solution because the 2.5 is the time and the 25 is the height, right? So we want to make sure, so 2.5. I'm going to go over here. Here we go. So this little point right here, right, was 2.5 comma 25, right, for our vertex. There we go. So his maximum height right, is going to be the y value of the vertex. So 25 inches. And then the next question, when does he reach his maximum height? That's going to be the x coordinate of our vertex. Right, so we want to make sure we're just answering the question that's being asked. Let's see. E says, when will Timmy land? Okay, well, back to Desmos. Here we go. Timmy lands at the x-intercept there, right? So the first intercept is 0, 0, and then he goes up and down, and then 5, 0. All right, so I'm going to go back to my picture here. All right, so I'm just going to go ahead and label these main points really quick. So 5, 0, and this was 0, 0, right? So when will Timmy land? So it's asking for time. So let me do purple. So you're going to say after 5 seconds. So when will he land? 5 seconds. And then it wants the domain and range of just his trip up and then down. So we talked about this in class, right? We've got to talk about the reasonable range or domain. Let's do domain first. So domain is this graph cannot go forever left or right, right? He's trapped, this parabola is trapped between these two walls. And these two walls start at 0 and end at 5, right? So that means our reasonable domain is all the x's between 0 and 5. And then, of course, these are going to be less than or equal to, since we can actually, he can be jumping over the river at 0 seconds and then finishes at 5 seconds and all the time in between. Okay. I'm going to put seconds right here, right? We're talking about a time that exists on his jump. And then your range is going to be, he's not going forever down, right? It's not like he hits the ground and keeps going, right? So there we go. So 0, right, is his lowest height, and then that 25 is his highest height. So as far as his height of his jump, it starts at 0, and it goes every inch between 0 and 25 at his highest point. All right. Oh, it's inches. Sorry. It's not a very high jump. I keep thinking it's feet. Okay. And there you go. So just answering questions based on and using Desmos to help you find those main points. All right, here we go. We're going to do some multiple choice. Guys, we don't want to, please don't ignore the multiple choice or think they're any less important, because they're actually worth a lot of points. There's no partial credit that I can give you here. Okay, so you want to make sure that you really try hard on the multiple choice. All right, so it says the graph of the quadratic parent function is shown. Okay, so there it is in blue, y equals x squared. Which equation will have a graph that will open in the opposite direction, right? So we want something that's going to do this and is narrower. So we want to be narrower and open down. So that's what we're looking for. Now, if you want to, you could totally put all of this into Desmos one at a time and see which one does that. I'm hoping, though, that do you guys see how we should be able to eliminate two answer choices right away? Right? What's the only way a graph can open down? Right? That means it has to have a negative a value. And it looks like B and C are the only ones that have negative a values. A and D are positive still, so they would still open up. Right? So it can't be A or D. So by process of elimination, we can just get rid of half of the answer choices right away. So that takes care of the opening in the opposite direction part. Now we need to talk about the narrower part. Well, remember, the only way a graph can get narrower, right, we talked about this in class, but that means it's getting skinnier. And the only way something that can get skinnier is if you stretch it vertically, so it has nowhere else to go but in and get skinnier, right? And so that means that A has to be a number greater than 1. Right? So if I make something twice as tall or 3 times as tall or 4 times as tall, right, it's going to have to get skinnier, right? And only one of these A values is a value greater than 1. I know they're both fractions, but 2/5 is 0.4, right? And 4/3 is 1 1/3, right? And so this guy is our winner, C. Okay. Now, if you are not catching on to that, or you're like, I might not remember that, either put it on your note card, right? Or you can throw that into Desmos, right? Let me just show you here really quick. Let me get rid of all this. I'm going to put in my parent function, y equals x squared, right? That's the one that, let me just use my home screen. There we go. That's the one they gave us. And then I'm going to type in y equals, I'm going to put in b, negative 2/5 x squared, okay? And then I'm going to type in y equals, because I've narrowed it down to two choices, so I may as well just type them both in. 4/3, kick it out, x squared, okay? All right, and out of, notice the color coding, right? You got the black and the red, right? So the black one, let me turn that off. Is the black one wider or narrower than my parent function? He's clearly wider, right? And then when I turn him off, do you see how the red one is narrower, right? If you turn them both on, you can clearly see that the red one is narrower than the parent function, the purple one at the top, right? So you could totally use Desmos to help you out if you struggle with the narrower versus wider situation, okay? All right, here we go. Looking at number 43. If the graph of the parabola of y equals x squared plus 1 is shifted left 3, what is the equation of the new graph? All right, well, remember, shifting left 3, that is a horizontal movement. So he has to be trapped inside with the x if I'm moving left or right. And remember, it's always the opposite. So I know that whatever function I pick, if it's going left 3, it has to have an x plus 3 squared somewhere in there, okay? And there's only one answer choice that has that, and it's D, okay? Let's just talk about these really quick, just to make sure. And you can also use Desmos for this too, right? You can type all this in and check. But remember, if it's hanging off the end as a constant, this would mean down 3, not left 3. This 3 is inside, which is great, but it's a minus 3. This would actually be right 3, not left 3. This 3 is also hanging off the end, like our k value, so this would actually be up 3. And this is the only one that has the positive 3 inside, which means left 3. Okay, so they've put 3's in every single one of them, but they all tell you something different depending on where they are in the function. And again, if you need to use Desmos, you totally can. All right, number 44, which ordered pair describes one of the roots of the quadratic equation 2x squared minus 4x plus 16? I don't know about you guys, but I'm totally just going to use Desmos here because it's a multiple choice question. So here we go. I'm going to go to Desmos and get rid of all that stuff. And I'm just going to type in y equals 2x squared minus 4x minus 16. And I'm just going to let Desmos tell me what those solutions are. I tap in my little dots. Looks like my solutions are negative 2, 0, and 4, 0. Okay, so I'm going to go back here. All right, I'm just going to write my two solutions down. Negative 2, 0, and 4, 0. So it says, which of the following is one of the roots? Well, this one, it kind of, don't get confused. That one's flipped around, right? And so the only one that matches one of those roots is 4, 0. Okay. All right, here we go. Number 45, a table of values for the quadratic function 2x squared plus 11x plus 5 is shown. What is the solution set for f of x equals 0? Now, don't get confused by this right here, right? Sorry. Don't get confused by this, right? This is just saying y equals 0, which means we're setting the equation equal to 0, which means we're finding the x-intercepts or the solutions, right? So that's all this is asking us to do. It's just trying to sound very fancy, okay? Well, clearly, if we're looking for y is 0, you can use Desmos if you want to because they literally gave you the function, right? But I don't really need Desmos because I'm looking for where y is 0. I'm looking for x-intercepts, right? And there they are right there. Now, instead of writing them as ordered pairs, we're used to writing it as negative 6, 0 and 7, 0. That's how we're used to writing our solutions. But they're writing them as a solution set. Now, we haven't really talked about this a lot, but a solution set is just where they take the two numbers and they put them in a pair of curly brackets. So our two solutions for x are -6 and 7. So they're just going to put those in curly brackets, and that's why the answer is B. Okay. All right, 3 more to go. Here we are. All right, number 46. Which equation best represents the graph shown? All right, so the first thing you want to do, and you can totally use Desmos. You can type all this into Desmos and see which one gives you the right value. So I'm going to narrow it down to 2 options, though. So here we go. It looks like one of our solutions is -1. All right, so -1. And this solution right here is 3. Now you want to think about what's happening here, because remember, all of these answer choices are in factored form, right? Which means they haven't finished solving them, because we would set them equal to 0, right? Now the fractions in the front don't contribute to your solution pool, but if you were to set all of these equal to 0 and then solve them, right, you would get x equals -3, right, because you'd have to subtract the 3 over, and x equals +1. Well, that is clearly not what is happening here. Erase all this. That does not give me -1 and +3, right? Same thing is going to happen on the next one, right? This is going to give me x equals -3 and x equals +1, so it's not that guy either. This one's going to give me x equals 3, because I would add the 3 over, and x equals -1, which is totally what's happening. But I'm also going to get those same 2 solutions for this one as well, right? So I've taken out half of my answer choices, so it's either C or D at this point, okay? Now, obviously, what it's going to come down to now between C and D is the 1/3 versus the 2/3, okay? So I would probably just go to Desmos if I were you, right? And I'm just going to type that in literally exactly as those answer choices are written. So on answer choice C, it's y equals 1/3. And I'm just going to type in the factored form, x -3. And if you didn't understand what I was doing earlier with those factored forms, then you can do this with all 4 answer choices if you need to. So there's that one. And then answer choice D is y equals 2/3, and then the same factors, x -3 and x +1. Okay, so notice they both have the solutions, right, of -1 and 3, but notice their vertex points are very different. Right, I wish I could put that one up here. Anywho, all right, so if we go back and look at our graph, hold on. I'm going to kind of eyeball what my vertex is, right? So 1, here's my vertex. That looks like 1 and like, you know, -2 point something, -2 point like 6 or 7-ish or something like that. I'm just kind of eyeballing it. So I need my graph that I just put on Desmos to have the same vertex, right? So I'm going to go over here. Let me kind of zoom in here. So to have a vertex of... Sorry, let me go in and see if it'll... Anyway, so I wanted what, 1 and -2. I can't write on here, right? But look at that point right there. And then look at this point right here, right? So one of my vertices is 1 -1.3, and the other one is 1 -2.667, right? So remember, I want this one, -1 point, or -2 point something, right? So that means the purple one is my winner, right? And so when I go over to the left and look at my purple one, that's the one with the 2/3 in the front, and that's answer choice D. All right, so again, I know that's kind of a lot of work in Desmos, but it's totally worth it to not miss a question, especially when Desmos will do it all for you, right? And you can, sorry, let me erase that. 1 -2.7. All right, here we go. Last couple. A part of a quadratic function is graphed. Okay, what is the domain and range of the function shown? Okay, now normally I know my answer choice right away is not A, because first of all, the domain is not all real numbers because there's no arrow on the right-hand side telling us he's going forever left. And the range can't possibly be all real numbers, right? So that's off the table. All right, so we need to, talk about our walls, right, for our domain and range, right? He's trying to go forever left, which he is, but he can't go forever right. So he hits a wall at an x value of 1. Well, if I hit a wall at an x value of 1, the entire graph is to the left of that, which means it's going to be x is everything less than or equal to 1. And then if we look at our y's, right, he's trying to go forever down, but he can't because he hits a wall, and that wall has a y value of 0. And the graph exists above that wall, so y is everything greater than or equal to 0. Right? It's all about, does the graph exist above the wall or below the wall? And for domain, does it exist to the left of the wall or right of the wall? Right? To get your less thans and greater thans. Right? So we're looking for the option that says less than or equal to 1 for the domain. Right? So it's definitely not B. Sorry, it's not B. C says domain is all real numbers less than or equal to 1. Yes. And the range is all real numbers greater than or equal to 0. Yes, that is exactly what I wrote. I am going to check D just to make sure. Domain is all real numbers less than or equal to 0. Oh, they swapped it, right? And then they said 0 on both, right? So that doesn't work, right? That should be greater than anyway, right? So it's definitely C. Right, but always read through all your answer choices just to make sure you are picking the right one and you didn't miss something. All right, and then our last one, what is the domain and range of the function below? All right, so you can just answer this without using Desmos, or you can totally use Desmos. I'm going to go ahead and graph it just so we can see. So I'm just going to type that whole function in, y equals, or you can put f of x, that's fine too, either one. 2 parentheses x plus 4 parentheses squared minus 6. All right, so here's our lovely quadratic right here. The only thing I really care about is the vertex is at -4, -6. Okay, so I'm going to kind of draw that over here just so y'all can have a visual here. All right, so our vertex point is -4, -6. And then arrows here and here, right? And so the domain, of course, is all real numbers because he is going to go forever left and forever to the right. So that's one of my options. Now the range, remember, he's going to hit a wall, right? So here's the wall he's hitting, right? And he has to turn around and go back up. And that wall has a y value of -6, right? That's the y value of the wall because that's the y value of the vertex. Right? And of course, my graph is everything above that, which means y is greater than or equal to -6, right? Which gives us this answer down here. So we want to make sure we're bubbling 1 for the domain and 1 for the range. Woo! All right, guys. Man, that was a lengthy review, but we are all done. Obviously, let me know if you have any questions or we need to go over any of that again. All right. Good luck, you guys.